Hello everyone, myself Anjali sir from JM University of AML. Our course name is Deep Learning and Large Language Model. The assignment is two deep learning optimization method and analyze their effect on CNN training for CIFAR-10 dataset. Our team members are SK Karthik, Vaibhav Girish Patil, Ventesh and Santosh. Our project introduction is that the convolution of neural networks are widely used for image classification tasks. The optimizers play a crucial role in CNN trainings that is affecting in convergence, speed and accuracy. The object of our project is to compare the performance Adam and RMSProp optimizers when training a CNN on the CAFR10 dataset in terms of convergence speed, training and validation accuracy, training stability, and loss behavior. The objective of our project is to evaluate the effect of different optimization algorithms by using CNN training performance. We compare the Adam and the Rams prop optimizers with the CFAR10 dataset to analyze training and validation accuracy, the loss, and the conversion speed for both the optimizers. We use it to identify which optimizer is more efficient and suitable for image classification tasks with CNNs. Now, next slide is continued by Vaibhav.
Move on to the dataset used for our experiment, the CIFAR 10 dataset. About the dataset, it is widely used benchmark dataset for image classification task in deep learning. It contains 60,000 color images of size 32 cross 32 pixels divided into 10 different classes. These 10 classes include common objects like airplanes, automobiles, birds, cats, dogs, frogs, horses, like this. Uh, Out of the total data set, 50,000 images are used for training and 10,000 for testing, which helps in evaluating model generalization. Uh, Before feeding images to the CNN, we applied basic preprocessing steps named normalization, which is scaled for pixel values between 0 and 1 to ensure uniform input, and label encoding. It converts class labels into categorical from from for multi-class classification. Uh, Overall, CIFAR 10 provides a balanced and challenging dataset for testing and efficiency of deep learning models like CNNs. Next, let's look at the architecture of our convolutional neural network used for image classification. We have input layer, uh, conventional 2D plus ReLU, max pooling 2D, conventional 2D plus ReLU, max pooling 2D, flatten, dense and output layers. The CNN starts by extracting low-level features like edges and colors in early layers, and as we move on deeper, it learns higher-level features like object shapes and textures. Finally, the dense and softer layers perform classification into the 10 categories. This CNN architecture provides a good balance between complexity and performance, making it ideal for experimenting with different optimizers like Adam and RMS propagation. Thank you.
Next one is the Adam optimizer, where Adam is a it is a type of a adaptive moment estimation where it combines momentum and RSMEC prop principles using running averages of a gradients and a squares, where the parameters are like we use a learning rate is equal to 0.001 for training, and where the beta 1 is equal to zero point 0.9 and beta 2 is equal to 0.99, where these values are used for the training the dataset, where epsilon is equal to 1e minus 8, which is the formula for the parameterization of our optimizer. Next is the result. For example, if our training accuracy is 90% and the validation accuracy is 84, it is a smooth and stable loss curves will be formed in the charts, and where it is a faster convergence within the fewer approaches, where approaches are like batches we use it in our training. for a dataset. In visual, we use a line graph of loss and accuracy over many batches. Next, next in RSMEC optimizer, where type it is a root mean square propagation, where it adjusts the learning rate based on a moving average of a squared gradient, helping stabilizing training. Whereas optimizer, where it uses a root mean square propagation with the adjustment of a learning rate based on a moving average of a square gradient. It's helping the stabilizing the training data, where it uses the parameters like a learning rate 0.001 and where p is equal to 0.9 and epsilon is equal to 1e minus 8, where these are the parameters we use it in optimizers, where root mean square uses only the uh, learning rate and epsilon with the sigma value, where it gives the training accuracy to 86% and validation accuracy till the 81%, where it is a moderate fluctuations in loss curve, but it gives a slightly slower convergence than Adam. To compare to the Adam, RSMS gives a slower convergence in a curve form, where training accuracy and validation accuracy is lower than the Adam's. Next will be continued by English.
Karthi, here is the comparison and optimizers of our project. Here is a matrix Adam and RMS prop, and average speed faster, and RMS root mean squared is a moderate, and validation accuracy is up to 83% to 85%, and here opposite is 80 to 82%, and training stability is high and medium, and loss cover is smooth and slightly noisy, and here root mean squared is the measure of a average magnitude of the single or a set of values. Next slide. Here is a key observations. And Adam achieves a highly accuracy and a faster convergence, and achieves higher accuracy and a faster convergence, making it a popular choice. And RMS proper effective but may require a fine tuning for optimal results. Optimizer choice is significantly impacts CNN training performance, emphasizing the importance of selecting the right optimizer for the your specific our specific problem. Next is continued by Santosh.
Optimizer selection strongly influence CNN performance. Adam provides faster convergence and higher accuracy on CIFAR 10. RMS Prof remaining a good choice for a task requiring controlled learning rate adaptation. Final recommendation Adam is preferred for general purpose CNN training, while RMS Prof may be used where stability and controlled updates are essential.
Here is our code where we done a Python programming, wherein at first we training the model with an Adam optimizer, where it trains nearly to a 30 batches, like 30 batches or an approach. And next is the final evaluation results, where it gives the Adam and the RMSE prop result, where our loss of the Adams is 0.7539 and accuracy is up to the 74%, where for RMSE prop loss is 0.85 and the accuracy is 70%. As now it plots to two different graphes, a training and validation accuracy and a training and validation loss. Where at first training and validation accuracy, where it gives a Adam train and value and RMSE train and RMSE value, where the blue color line is for the RMSE train and green color line for the RMSE from, where the Adam strain is a greater value than the RMSE prop, where it use the more accuracy and validation points in the training and the validation loss, where the again adapt train use the less value and makes it the perfect for the training and validation loss. Here is our accuracy up to the 74% for the Adam, which is best for our prompt. Thank you.
Next. Thank you.